When Carl Friedrich Gauss was a little boy, one of his teachers, tired of having this young man finish all the assignments early, said, "Carl, I'd like you to add up all the numbers from 1 to 100. And he expected Carl to do 1 plus 2 plus 3 plus 4 plus 5 plus, and all the way up to 100. Of course, Carl was a little bit smarter than the average student, and Carl thought and said, "Gee, I bet if I took the numbers from 1 to 100, and then I paired them up with the numbers from 100 to 1, all of these sums are going to add up to be 101. And there are going to be 100 of them. So if I take 101 times 100, I will get that sum. But wait a minute, I'm adding every number twice, so I better divide by 2. And Carl came up with the answer of 5,050 in just a short amount of time. And this poor teacher then had to find something else for Carl to do because he now was done with the assignment.
Version of the story. The other version is that he gave it to the whole class because he wanted the class to leave them alone. But either way, that's how these things get developed. It's not like he invented it and said, hey, this is the formula we're going to use, because if it doesn't work, then it doesn't make any sense. But it's just, he was looking at the patterns and, figuring it out from there. He was in elementary school. He was really young. I don't remember what the age was, but I think that's that varies in which stories you hear anyway. But I know, I have to learn to add. Isn't that crazy? All right. Okay, we are going to start with the one that says Pascal's triangle. Now, Blaise Pascal was also a mathematician, and he had to be a cool dude because his name is Blaise, right? Blaise. And he wasn't even trying to be trendy, I'm sure. So we've got Pascal's triangle, which you may have encountered before sometime in your math world, but this is actually taking us to something very much more intense than just this triangle. It was discovered in the 13th century by French mathematician Blaise Pascal. That's why we call it Pascal's triangle. Each number in Pascal's triangle is the sum of the two numbers diagonally above it. All outside numbers are 1. So for this triangle here, we've got all the outsides are 1, 1, 1, 1, and 1, right? And then where this 2 comes from, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3. That's where those are coming from. So 1 plus 3 then is 4. That's what goes there. 3 plus 3 is 6. 3 plus 1 is 4. And that gives you that row, right? So now you do row 5. All right. Pretty simple, yes? All right, so what do you notice about this triangle? What are a couple things you might notice? Besides, obviously, ones are all on the outside. It's symmetric. That's important. It's symmetric. What row number does it start with? Row 0. That's hugely important, okay? Row 0. So the row number actually corresponds to the second number in the row. You notice this? This is row 1, 2, 3, 4, and 5. Okay, so but you start with row 0. Very important if you're counting down the triangle or trying to figure out some other stuff that we're going to get into. So we do this to eventually get to the binomial theorem, which we'll get to at the end of class. And so we have what's called binomial expansion. This is a binomial, 2 terms, hence the word binomial. And so this is a plus b to the nth power, which does not become a to the nth plus b to the nth, right? It doesn't work that way. So instead, we've got a plus b to the 0 power, which is 1, because anything to the 0 power is 1, except 0. And then a plus b to the first power, so that's just a plus b. A plus b squared, which is not a squared plus b squared, becomes this. So basically, these are all done out for you, so we didn't have to take forever actually multiplying those out. But doing a plus b to the 5th, if I gave that to you and I said, do it, expand it on your own, that's going to take a while, right? You're capable of it. It's not necessarily difficult. It's just tedious, and it would take a while. But we're going to be able to get to a shortcut there. But so what do you notice about the coefficients? Look at the coefficients in front of the variables here. We've got this is 1 and 1, right? This is 1, 2, and 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1, right? Okay, it's coming from Pascal's triangle, right? You got it? You see the numbers? I put in the ones because we don't put them there. We just, think about what they are. But those are the same numbers if you look up at Pascal's triangle, right? So they are the, let's see, it should say it corresponds, or let's say it matches, we'll say matches Pascal's triangle. Right? And it's symmetric as well. Now that's all variables, just A and B. If A and B become numbers or have numbers with them, then it's not going to be quite as obvious as looking at it, but that's where it's all coming from, right? So there's some things that we need to think about as we go through this. It says other important patterns in the binomial expansion, the total number of terms. So look up there and count the terms in each one of these expansions and see how they correspond, how you could explain to me how they relate to n. N plus 1. Like this is n, this is 5, right? So I've got 1, 2, 3, 4, 5, 6 terms. N is 4 right here. I have 1, 2, 3, 4, 5 terms. So the total number of terms is always n plus 1. And then it says first term, but it shouldn't say term. It should say first coefficient. So that's a long word we will abbreviate. And it should be last coefficient. So what's the first coefficient every time? 1. What's the last coefficient? 1. Okay? Starts and ends with 1, just like the rows of the triangle do. What's happening with the exponent of a from left to right? Of a. It decreases by how much? 1. The exponent of a decreases by 1 from left to right. What happens to the exponent of b? It increases by 1. And if you look at each term and you add the exponents, what's the sum of the exponents in each term? It's like, just look at this last one. This is just 5. This is going to be 4 plus 1. This is going to be 3 plus 2, 2 plus 3, 4 plus 1, 5. What's the sum each time? It's n, right? It's just n. So when we do expand these, that's a good way to check yourself to make sure you didn't miss anything or whatever, okay? So we are going to do number 1, and then because this is a super basic one that just has variables, and most of them aren't going to have that, but it'll get you kind of the idea of what's going on. So it says, use Pascal's triangle to expand each binomial. So the first thing we want to do, the n equals 6, right? So we need row 6 of Pascal's triangle. We did rows 1 through 5, so since we have that, you should be able to look up there and then figure out what row 6 is. So write down what row 6 is right here. Do y'all agree with that? Okay. So now we're going to use that, going from left to right here. We have the first term. My first coefficient is going to be 1. And then it's going to be a to the 6th power, b to the 0 power, plus 6, which is my next one, times a to the 5th, b to the 1st, plus, then I'm at 15 times a to the 4th, b squared, plus, then I'm at 20, a cubed, b cubed. See if you can finish this up without me saying it, without you looking up here. And I already know what some questions are going to be, so just finish that. So do we have to write b to the 0, and do we have to write the 1, and do we have to write a to the 1st? And kind of yes, because they're not all going to be this simple. And if you don't, you might regret it. Okay, so do you absolutely have to? No, but you better make sure that you're not messing anything up. Because this one, we could have done it probably all in one step and not have to clean anything up. That's not going to be the case on all of them, so you're going to have to clean something up anyway, and it's kind of easier to kind of keep up with everything. So you can double check yourself that you actually have, these add up to give you 6 every time, so you don't just accidentally write the wrong number, because sometimes that's why we miss things, right? So in the end, what this gives me is a to the 6th plus 6a to the 5th times b, plus 15 a to the 4th b squared, plus 20 a cubed b cubed, plus 15 a squared b to the 4th, plus 6a b to the 5th, plus b to the 6th. And we're done. What questions do you have?
We don't have to write the a plus b to the 6th.
No, it's okay. All right, any questions at all? All right. So let's do number 2 back here. All right. So I have x plus 2 to the 7th. Let's rewrite Pascal's triangle real quick just to the 7th row. So it's 1, 1, 1, then 1, 2, 1. Once you get it started, then it's not like you've memorized it. You just figure it out every time. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, and 1, 7, 21, 35, 35, 21, 7, and 1. Now I don't need to go any farther because it's just to the 7th power. Okay. So what I need here to do this, since n equals 7, I need row 7. And row 7 is 1, 7, 21, 35, 35, 21, 7, 1. Okay. So I start with my first coefficient is 1. So it's going to be 1. This is A, this is B, right? So it's 1 times A to the 7th, B to the 0. Plus, my second number there is 7 times A, which is x, to the 6th, B to the 1st, and B is 2. Plus, then I had to get to 21. 21, x to the 5th, 2 to the 2nd. Plus, 35, x to the 4th, 2 to the 3rd. Let's see if you can finish expanding that without me talking you through it. All right, do y'all agree with that expansion up to that point? So then when we start cleaning it up, this first term here is just x to the 7th. Then in this term, I have 2 to the 1st and 7, so I have to multiply those. That's going to give me 14 x to the 6th. Then I move on to this one. 2 squared is 4 times 21 is 84 x to the 5th. Plus 2 cubed is 8 times 35 gives me 280 x to the 4th. Then 2 to the 4th times 35, which I know that you're capable of doing on the calculator, so I'm just going to give these to you. You get 560 x cubed. Then here I'd have to do 2 to the 5th times 21, which would give me 672 x squared. Then I would do 2 to the 6th times 7. It's going to give me 448 x plus 2 to the 7th, which is 128. And there is my expansion. Way better than having to actually multiply it all out. What questions do you have at this point? All right. You're going to do 14. No, not 14. You're going to do number 4, but I'm going to get you started. So number 4, what does n equal? 5. N equals 5, and so we need the 5th, so we need row 5, right? And row 5 is 1, 5, 10, 10, 5, 1. When you put this in here, okay, A is equal to 4C, B is equal to negative 3D. And you need to make sure you write down parentheses and all that good kind of stuff correctly. So it's going to start off with 1 times 4C to the 5th times negative 3D to the 0, like so, okay? So you finish expanding it and actually find the numbers and everything in the end, calculate it all out. Oh, get over yourself. Finish it up. Don't stop where I stopped. And you've got a calculator, so it should help you get through it. Take your thing out, please. Careful with your signs. Those are the kinds of things that'll mess you up. This is the review that we're going to get tomorrow. The numbers make no sense as usual, so just ignore that. Okay. And I'll have a video up because the test is Thursday. But like I said, Wednesday when you're in class, you can check it with her review too. So when you're done, check yourself, but don't check yourself until you're done, because once you actually making sure you can get these numbers. Ask me questions if you have questions. Yes, ma'am. How did I get what negatives? What's a negative 3D? Yeah. Got to make sure you have a negative 3D in there. And so those signs should alternate from even exponents to odd exponents, and so they'll go back and forth from positive and negative. Okay, so I'll tell you what, if you have at least some of the final answer, like some of what I have in green, make sure you agree with however much of it you have. And then if you do, then just copy down the rest so that we can move on. But if you don't agree with whatever you have done, make sure that you let me know, because I want to make sure. If you can type what he doesn't agree with me, why not? Jeez, y'all silly. He's bonkers. All right, are we good? Do we have any questions? All right, so grab the next sheet of paper. It's going to go on page 159. And I'm going to get to the binomial theorem, which is all going to be connected to Pascal's triangle here. So here's the first part of Pascal's triangle again. And notice that each element of Pascal's triangle is assigned a row n and an element r number. Oh, marked out r. So n is the row number, r is the element number. I know the word row starts with r, but r does not mean row, okay? And if you look at this, they're not calling them terms, they're calling them elements, right? The elements and the rows both start with 0. That's very important because these are going to be connected to the terms that we have in our binomial expansions, but the term number and the element number are not the same thing because we start counting at 0 each time, right? So we're going to start by just talking about the triangle itself and not necessarily tied to the binomial theorem. And here on these two things, there is not a fraction bar missing. I know when it looks like that, usually my fraction bars have disappeared. They did not disappear. They were never there. It's not a fraction, okay? So I don't want you to just assume that you're supposed to go put fraction bars in there. So it's not. It's a different way to write combinations. This n element or n things taken r at a time, that's your combination. In geometry, when you do probability at the end, you have combinations and permutations, and that's where that stuff should have come in the first time. Then the little exclamation point, what does the exclamation point mean? What's the word for that? Factorial. Okay, means factorial, which means if I have 5 factorial, that's 5 times 4 times 3 times 2 times 1. 100 factorial is 100 times 99 times 98 times 97 and so forth and so on. You need to know how to handle factorials and these types of things by hand without a calculator and also on a calculator. All right, it's an important skill to have in both ways. So this combination, we may have shown you this in geometry. That's a different way to write it. Chances are pretty good. We just kept it like this just because it could be confusing anyway. Why introduce more notation? But it means the same thing. Again, not a fraction. But the combination of n things taken r at a time is n factorial over r factorial times n minus r factorial. And the n here is the row number. R is the element number. So when I know arth is a weird thing to say, but you got nth and arth. So the 6th row, 3rd element, that means that n equals 6, r equals 3, right? So that means when I substitute it in here, that I get it looks like this, 6, 3, again, not a fraction. That's equal to, this is 6, this is 3. So when I substitute it in, it is 6 factorial over 3 factorial times 6 minus 3 factorial, which is the same as 6 factorial over 3 factorial, 3 factorial. You don't have to write all that out every single time. The first time I want you to know how it's all related, but then we'll go from there. So over here, I'm going to do the work so it's not crammed all in that box. We're going to do this one by hand. So when you do this, you can't just cancel things out like I can't reduce the 6 and the 3 right there or anything like that. But you start writing out the numerator until it matches the denominator. So 6 factorial is 6 times 4. It's 6 times 5 times 4 times 3 factorial. Over, well, the first thing is 3 factorial. Those match. That's good. Then times, the next one I'm going to write out, 3 times 2 times 1. When I go to reduce, well, 3 factorial and 3 factorial can cancel each other out. 2 times 3, that's just a normal 2 times 3, gives me a normal 6. So all I'm left with is 5 times 4, and my answer is 20. Okay, make sense? We good? So when we jump to number 3, we're going to do, it's the 18th row, second element, right? So that means that's going to be 18 factorial over 2 factorial times what? 18 minus 2, which is 16 factorial. So those numbers are way bigger, but that doesn't mean that this is any more difficult. So I start with 18 times 17 times 16 factorial. Well, that matches the 16. So then I do 2 times 1 times 16 factorial. These cancel out. 18 can be divided by 2, which is 9. So in the end, you just have 9 times 17. And what's 9 times 17? $153. Okay. So when the numbers are small enough to where it's not a nightmare to do by hand, it could totally be a non-calculator type of question with any kind of factorial. But when the numbers get bigger, or even if they're not bigger, calculator may come into play. So I'm going to show you a couple of different ways to handle this on the calculator. Let's look at number 4. This is the 25th row, 14th element, right? Which means that that's going to be the same thing as 2514 like this, which is the same thing as 25 factorial over 14 factorial times what? (25 minus 14, which is 11 factorial. Okay, so you're capable of doing that by hand. Like, it's not like you have to have the calculator. It wouldn't be any fun because it might be fun to you, I don't know, but it would, it's a big number. So instead, I want you to look at your calculator, and you're going to type it in exactly like you see it right here with the factorial signs. Well, almost exactly. Notice that right under the mode key, it's x inverse, but above that, you have the x factorial key. So you do shift to get the little exclamation point. But if I remember correctly, when I did this, like in the denominator, you have to put the times or it doesn't like it and it gives you an error, I think. But if you get an error, it's probably because you didn't put a times there. So just use the fraction key, make it look just like this. It's a big number. Yes, that's why I said it would. Even though you're capable of doing it by hand, nobody would make this an actual thing for that. So 4,457,400. Make sure you actually get that, doing it that way, and then I'm going to show you one more way. All right, everybody got that? Okay, you got to make sure you're actually pushing these buttons. Now, you can also put it into the calculator pretty much just like this. If you look at the division key, right above the division key, you see that NCR key. The thing is, when you type this in, with a clear screen, you have to type in the 25, then you do shift division, and it brings up the C, and then you put in the 14. They don't look like subscripts on the calculator, but it does it the correct way. So you do it that way, and then bam, there's your 4 million, okay? So it's good to know how to do it both ways, because maybe you have a calculator that doesn't have that NCR key, but it does have factorial or whatever. But again, you also have to know how to do it by hand, okay? Did everybody get that? Any questions at this point? Because I can't record and show you my document camera, so I'm still working on trying to figure out what to do with that. All right, so let's look at how this comes with our binomials here. What? Okay. All right, so if I want to find binomial terms, remember those were just elements in the triangle itself. So when I have the binomial expansion of a plus b to the nth power, all right, that is going to be, it's the r plus 1th term, which is a very strange thing to say. So let's say that I did a plus b to the 5th power, right? So a plus b to the 5th power, this goes with term 1, term 2, term 3, term 4, term 5, term 6. So for the 5th term, this is what I would use for my coefficient, right? But that's the 4th element in the triangle. So 4th element is the 5th term. It's always like what? That's why it's r plus 1, because r is the element number. So that means that the r is equal to the term number, then what? Minus 1. To find r, it's the term number minus 1, because r plus 1 is the term number. So r is what we actually need. This is, when we look at, we're going to do number 5, I think is the one I wanted to start with. Yeah, we're going to do number 5. So the n, this is n equals 10. The 8th term means that r equals what? 7. So I only want one term out of the entire expansion. I don't have to expand the entire thing. I don't have to find the 10 rows of Pascal's triangle. You could, but totally don't need to. So instead, the way you write this out then is going to be that you have the 10th row, 7th element, right? And then this is going to be, and notice this says you do this right here, and then it's a to the n minus r power times b to the r. So a to the 10 minus 7 power times b to the 7th power. That's how you figure out the exponents there. So use your calculator to find this combination here, which is not 10/7, right? What do you get for your number? $120. So this is going to equal 120, a to the 3rd, b to the 7th. That is the 8th term of a plus b to the 10th power. All right. Any questions about that? You do this right here. Either that or you do this, or it's the same. Because you don't need to. Just let the calculator do it for you. It's all good. All right, so let's do number 10. I have 3a minus 2 to the 7th power, and I want the 4th term. So what does n equal? 7. What does r equal? 3. So that means I want the 7th term, or I'm sorry, the 7th row, the 3rd element, if I can write this correctly, there we go. And then it's going to be a, so that's 3a, parentheses, n minus r, 7 minus 3, times negative 2, right, to the 3rd power. That negative stays with it, because it's an a plus b rule. So let's just find what's this combination of 7, 3. 35. This is going to give me 35. That's what this gives me. This is 3a to the 4th power, right? So what's 3 to the 4th power? It's 81. So that's times 81a to the 4th times negative 2 to the 3rd is negative 8. Now, it's okay to do that all in one step in your calculator. I just want to make sure that you know where the numbers are coming from. So when I multiply all that out, that gives me a negative 22,680 a to the 4th. Make sure that's what you're getting. What questions do you have? All right, so if you can find one term, then you can find the entire expansion. And that's what the binomial theorem actually is. So the binomial theorem looks like a crazy, terrible looking thing, but it's not that bad. This is your combinations for each one, right? The nth row, you start with the 0 element, element 1, 2, 3, and so forth, all the way up into whatever n is. And so this sigma, what does sigma mean we're doing? Summing it up. So basically we're adding them all up. And in this case, it's not going to give us just a number like it was, because well, it could, depending on, but it would be a weird way to do the problem. But it's going to give us an equation because it's going to have variables in it. But you do the combination, and then a to the n minus r power, b to the r, just like we did for each term. So when we want to expand the binomial itself, you have to just do the whole thing, right? So here, what does n equal? 6. Okay, so we're using the 6th row. That means in our little combination thing, 6 is going to be the first number every time. So it's going to be 6th row, 0th element. And then that starts with a to the n minus r power, so 6 minus 0 is 6, and then 2 to the 0 power. Plus, and then this is going to be 6, 1, a to the 5th, 2 to the 1st. Plus, then it's 6, 2, a to the 4th, 2 to the 2nd. Plus, then 6, 3, a to the 3rd, 2 to the 3rd. Plus 6, 4, a to the 2nd, 2 to the 4th. Plus 6, 5, a to the 1st, 2 to the 5th. Plus 6, 6, a to the 0, 2 to the 6th. Then once you write it all out, I'd check myself if I were you. Make sure that you've started with 6 on all of them. And then it goes 0, 1, 2, 3, 4, 5, 6, all the way to 6. And also you can double check that your exponents all add up to 6 all along the way before you start actually finding numbers. Okay? What questions do you have right now? All right, so then we clean this up a little bit. Well, what do you know the first coefficient is? What does this have to be to make sense? It's 1, right? And then it's going to be a to the 6th. So it just starts with a to the 6th. And then if this is a 6th row, you know the second one has to be 6, right? So this right here is going to have to give me 6, but it's going to be times 2. So that's going to be 12 times a to the 5th. Or you plug it in and do this CR thing. It's fine. So go ahead and find the next 2 terms. We'll make sure we agree on those, and then I'll just give you the rest. Just find the a to the 4th and a to the 3rd terms. Ask me questions if you've got them. And then if you agree with me on the a to the 4th and a to the 3rd, then you can just write the rest of them down. Because I would think that you could find the rest if you found those. All right, do you have any questions at this point? Yes. What's the question? Go ahead. No, okay, ask me a question. Are you confused as to how I wrote down what I have in pink? Or how I got what I got in purple? Okay, well, if you do the NCR in your calculator for this, it's going to give you 1. And then 2 to the 0 power is 1, so that just leaves me a to the 6th. And then 6 things taken one at a time. Again, you can substitute that in your calculator. It's going to give you 6. But then you also have 2 to the 1st, so you have to multiply to give you 12. So then you use your calculator to find this, and you multiply it by 4. That's how you get this number right here. Okay, that makes sense? All right, anything else? All right, then y'all do 14 on your own. 100%. finish it. I haven't even written anything down. Boy, go with it. So if you've got at least the first couple of the last terms finished, make sure we agree, and then you can copy the rest down because I think we're running a little short on time. Yes, we are. And what questions do you have? Anything? Okay. All right, sorry. Didn't give you enough time to finish that. But you get it copied down before you leave. Make sure you grab your homework and your quizzes that I passed back. Have a great day.